The answer to number 10 is 100. The answer to 12 is 52. The answer to 14 is 0. 16, you get 1/5, but it does not work when you plug it back in. 18, you get 0. 20, you get 1. 22, you get 3 and -3. 24, you get 0 and 9. Then we go to 26, and you get -4 and 3. -4 does not work. For 28, you get x equals -2, and -2 does not work. For 30, you get 1/3, and 1/3 does not work. For 32, you get 4 and -2, and -2 does not work. For 48, you get the square root of 2 and the negative square root of 2. For 50, you get the square root of 5 and the negative square root of 5. 52, you get the 2 and -2. 54, you get 2 and -1. Then we go all the way to 102, and you get x is 0, x is 1, and x is -1. 104, you get x is 0, x is 2, x is -2. 106, you get x is 0, x is -7, x is 1. 108, you get x is 1, x is -1, x is -4. For 110, you get x is 1, x is -1, and x is 3. That was your homework. So please come with questions for next time about that. You have just gotten a quiz back, and hopefully you did awesome on it. I thought we were, never mind. All right, so here we have an absolute value equation. Absolute value means the distance a number is away from 0. So inside of here could be 5, as the absolute value of 5 is 5. Or it could be -5 inside there, because the absolute value of -5 is also 5. So I'm going to set this equal to 5 as well as -5. And the reason I set it equal to 5 and to -5 is because both answers, both expressions, will equal 5 if you had them inside the absolute value. So solve each one for x. So subtract 3. So 2x equals 2. Divide by 2 and you get 1. Subtract 3. 2x equals -8. Divide by 2 and you get -4. And you're done. So you have two solutions because there are 2 times on the number line when you get the absolute value to equal 5. Here we have an absolute value plus something equals 13. On our last example, we did not have this value there. So we could go ahead and write our 2 equations. Well, on this one, you need to move that first. So you have to isolate your absolute value. Just like on our square root and cube root problems that we just graded, you had to isolate that before you could get rid of it. So we're isolating this. Now we write our 2 equations. 1 minus 4t equals 5, and 1 minus 4t equals -5. So solve here. Subtract 1. Divide by -4. You get -1. Over here, subtract 1. So you're doing the same steps, but you're going to get a different answer. When you divide by 4, you get 3/2. So we have 2 different answers. Check them. See if they work. All right. On these problems, here is our old school way of graphing. Or not our old school. Here's the new school way of graphing. Our old school way of graphing would be a closed dot with a line to a closed dot. These have brackets. Remember, brackets means it includes, so that's why I did a closed dot. So it wants us to express it in interval notation. So this is easy because it does it pretty much for you. So you do a bracket, 0, comma, 2. Close the bracket. You're done. Now it says express it in inequality form. This one's a little bit harder. We're going to go 0 is less than or equal to x. Remember it was equal to because it was a bracket. less than or equal to 2. So what that says is x is between those two values. All right, for this one down here, we have a bracket, but we also have a parenthesis. A parenthesis would mean an open circle. That's our old school way of doing it. So we're going to do our interval notation, which to me is silly because they do it pretty much for you. So we have a bracket, 0, comma, 3 with a parenthesis. We're going to go between 0 and 3. But the 3 I'm not going to put equal to because it was a parenthesis. And that's all you have to do. So on these ones, it wants us to write it in interval notation and graph it on a number line. So we have 0 is less than or equal to x, which is less than or equal to 4. So that tells us equal to is a bracket. We're going to go 0, comma, 4, bracket. Try this one on your own. You should get 4, comma, 6. The 4 has a bracket, the 6 has a parenthesis because it is not equal to. On a number line, you can graph the old school way or the new school way. Old school would be a closed dot to a closed dot. New school would be a bracket to a bracket. For this one, we have from 4 to 6. We have a bracket to a parenthesis in between, or a closed dot to an open dot. Yay, go you! Alright, so we've solved equations. Now we're going to start solving some inequalities. They work the same way, except when you multiply or divide by a negative, you must, this is the key, you must flip inequality symbol. So let's solve this just like we would an equation. We would move the 2 by subtracting. You would divide by the 3, negative, so you get negative 1. Since this was a negative 3 that you divided by, you flip your inequality symbol, and you're done. All right, see if you can do this one on your own. Pause the video, start it back up. All right, so there's two options. You can distribute that negative 3. So add 3, divide by 3. Or, if you want to divide by the negative 3 first, you would have 1 minus x is greater than negative 4. You have to flip the symbol because you divided by a negative number. Now move your 1, you get negative 5. Now divide by a negative 1, and that's where we get positive 5 like we did over here. Our symbol is greater than, we divide it by a negative, flip the symbol. There you go, you. What? Two inequality symbols all jammed together? I don't know what that means. It's a compound inequality. So what you're going to do is you're going to look at this chunk first. So negative 5 is less than or equal to 4 minus 3x. Solve it. So negative 9 is less than or equal to negative 3x. So 3 greater than or equal to x. Why did I flip the symbol? I divided by a negative. Alright, so then, after that, you look at this half. So you take off from the inequality symbol over. So then we have 4 minus 3x is less than or equal to 2. Solve it the same way. So negative 3x is less than or equal to negative 2. Divide by that negative 3. So yes, you must flip your symbol. And there you go. There's your two answers. Oh man, we just learned about absolute value equations. Now we have to do inequalities? Yes. They work the same way. Your absolute value has to be isolated, so it is. So we set it less than to 6. You also have to do another one to negative 6. When you do the negative one, you flip your inequality symbol. And some of you are like, why do you have to flip the symbol? Think of it this way. You're dividing by a negative, so that's why we're going to flip the symbol. So here is our first answer, and here is our second answer. So that one did not require any work for us to do. All right, so then we do this one. See if you can do it on your own. Absolute value is isolated, so you can write your two inequalities greater than negative 15. Solve each one by dividing by 3. You're going to get x is less than 5, and x is greater than negative 5. And you're done. All right, here our absolute value is not by itself, so you must get it there. So we have to subtract 2 first. So you get less than 1. Now you rewrite and got x minus 2 is less than 1, and x minus 2 is greater than negative 1. Solve it. So we add 2, so you get 3, and add 2, and you get 1. So x is less than 3, and x is greater than 1. Yay, go you. That is the end of the PowerPoint. Please come with questions for next time. Absolute value can be tricky. The key is to make 2 separate equations or 2 separate inequalities.